Welcome to this video on blockchain. I am Sumit Khanna. I am Chief Operating Officer for Neev Credit, an education financing company. Blockchain is a very interesting concept which we will cover in 4 broad topics: concept of blockchain, cryptocurrency versus blockchain, pros and cons of blockchain, blockchain technology, and few use cases. Let us now look at the concept of blockchain. Layman's definition. Blockchain is an ever-growing, secure, shared record-keeping system in which each user of the data holds a copy of the records, which can only be updated if all parties involved in the transaction agree to update. Technical definition. Blockchain is a peer-to-peer distributed ledger that is cryptographically secure, append-only, immutable, that is extremely hard to change, and updatable only via consensus or agreement among peers. Blockchains can broadly be defined as a new type of network infrastructure, a way to organize how information and value moves around on the internet, that creates trust in networks by introducing distributed verifiability, auditability, and consensus. Blockchains create trust by acting as a shared database distributed across vast peer-to-peer networks that have no single point of failure and no single source of truth, implying that no individual entity can own a blockchain network and no single entity can modify the data stored on it unilaterally without the consensus of its peers. New data can be added to a blockchain only through agreement between the various nodes of the network, a mechanism known as distributed consensus. Each node of the network keeps its own copy of blockchain's data and keeps the other nodes honest. If one node changes its local copy, the other nodes rejects it. For any update, blockchain technology allows all network participants to reach an agreement commonly known as consensus. This is what gives it the power of decentralization. In this scenario, no central authority is in control of updating the ledger. Blockchains leverage techniques from a field of mathematics and computer science known as cryptography to sign every transaction. Blocks in the chain are cryptographically secured, which makes the ledger secure against tampering and misuse. Blockchains record information on a timestamp chain that extends forward infinitely. New data is added to the end, and once added, it is permanent. Older data can neither be removed nor modified because a snapshot of it is captured in the blocks of data that comes after it. Append-only property of blockchain implies that once data is added to the blockchain, it is almost impossible to change that data and can be considered practically immutable. Now let us understand the concept of smart contracts. Smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can be immediately certain of the outcome without any intermediaries' involvement or time loss. Cryptocurrency versus blockchain. Cryptocurrency like Bitcoin are often confused with blockchain. It is to be noted that cryptocurrencies are evolved on the blockchain technologies because of common features like peer-to-peer transaction, use of cryptography, and distributed ledger, etc. However, please remember, all blockchain outcomes are not cryptocurrency. This shall be clear when we discuss few use cases of blockchain technology later in this video. Now, we will look at major pros and cons of blockchain technology. Pros of blockchain. Disintermediation. Since blockchain runs on a distributed system, it removes intermediaries. Even if intermediaries exist, the system runs smoothly without worrying about the trust factor. Immutability and transparency. Cryptographic hashing plays a huge role in maintaining an immutable structure. Speed. Transactions can be completed at much faster pace with the use of blockchain technology. Improved traceability. Blockchain enables traceability of data from very source to end point. Now let's look at the cons of blockchain. Redundant performance. The computation needs of this technology are more repetitive than centralized servers. It's because every time the ledger is updated, all the nodes need to update their version of the ledger as well. Integration concerns. Blockchain technologies don't have the capability to work along with the legacy networks. Legacy network needs to be completely replaced with blockchain technology to be able to function, which leads to integration challenges. Energy consumption. Since consensus process in the blockchain requires lot of computational power, it increases overall power consumption. High cost. For some industries, replacing legal system with blockchain technology may lead to high cost depending on the features or solutions being implemented. Use cases of blockchain. Blockchain application in banking and financial markets. Decentralized finance is emerging financial technology based on secure distributed ledgers similar to those used by cryptocurrencies. The system removes the control banks and institutions have on money, financial products, and financial services. Decentralized finance or DeFi uses emerging technology to remove third parties in financial transactions. Two of DeFi's goals are to reduce transaction times and increase access to financial services. Blockchain application in supply chain. Blockchain technology is being used to increase supply chain transparency, build resilient supply chain smart contracts, streamline supplier onboarding. Few use cases can be noticed in vaccine distribution network, container logistics, etc. Blockchain application in education. Blockchain technology has been implemented in declaration of academic results and its transmission to students for future records. Thanks for watching, and I hope you have enjoyed this video on blockchain.